Your scraper works fine on page 1. It works on page 10 and on page 100. Then somewhere past a few thousand requests, the blocks start, captures appear, response bodies come back empty, connections hang and die for no reason you can see. Your code did not change, the volume did. This is the part of scraping that nobody warns you about, the part where everything that worked at small scale quietly falls apart at large scale. In this video, I am going to walk you through how to scrape at scale without getting your apps burned using mobile proxies and Playwright with rotation built in from the start. I run a hardware proxy farm in Singapore. Real phones, real SIM cards from Singtel, M1 and StarHub on the live carrier network. So when a scrape gets blocked at volume, I have usually seen the exact pattern before, and I can tell you whether it's the IP type, the request pace, your concurrency, or the target site fighting back. Let me go through the things that actually matter when you take a scraper from 100 requests to 100,000. Start with why your data center IPs get blocked so fast. Data center proxies are cheap and they are fast, and that is the entire appeal. The problem is they are trivial to spot. They live in known IP ranges owned by hosting companies, and every serious anti-bot system has those ranges mapped already. One request from a data center IP is fine. 1,000 requests an hour, all from the same handful of ranges, with nothing human looking around them, is a pattern a machine catches instantly. And here is the part people miss. Sites flag the whole ASIN, not just the single IP. So when you rotate to the next data center IP in the same block, you have changed nothing that matters. You are still the same data center, still the same fingerprint, just wearing a slightly different number. The deeper issue is that there is no cover. A real website gets traffic from thousands of normal phones and home connections all day long. Your data center IPs do not blend into any of that. They stand apart as exactly what they are, a server pretending to be a person, at small volume that pretends holds. At scale, it falls apart because the sheer regularity of the traffic gives you away. The requests come in too evenly, too fast, from too few addresses, and the headers never vary the way real browsers do. Any one signal might be excusable. All of them together at volume is a confession. And the blocks rarely come back as honest blocks. You expect a clean status code that says you are rate limited, and instead you get something murkier. The page loads, but the data you wanted is gone. The site quietly feeds you stale or fake numbers to poison your dataset. By the time you notice, you have scraped 10,000 pages of garbage and trusted all of it. So scaling is not just about staying connected, it is about staying believable enough that the site keeps handing you the real thing. Now think about what changes when your traffic looks like a real Singapore phone. A mobile IP belongs to a real SIM on a real carrier, and it sits behind something called carrier-grade NAT. That sounds technical, but the idea is simple. Carrier NAT means one public IP is shared by a lot of real subscribers at the same time. So when a site looks at that IP, it does not see one suspicious scraper. It sees an address that could be dozens of genuine customers on their phones. Blocking that IP means blocking real paying users of the carrier, so sites are far more cautious about doing it. Your scraper hides inside real human traffic instead of standing out against it. That is the whole reason mobile survives at scale, where data center does not. Let me describe the Playwright setup in plain words because it is simpler than people expect. Playwright lets you pass proxy settings right into the launch call when you start the browser. You give it four things. You point the browser at the proxy host, you give it the port, and you give it the username and the password. That is it. The host stays constant and the rotating IP leaves behind it, so your browser always talks to the same stable gateway while the actual address changes underneath. I am not going to read code out loud here, but if you picture a launch line with a server field, a username field, and a password field, that is the entire connection. Everything else in your scraper stays exactly the same. One detail in that setup matters more than the rest, and it is the protocol. Use SOX5H with the letter H on the end, not plain SOX5. That little h tells the client to resolve DNS through the proxy tunnel instead of on your own machine. With plain socks 5, your local computer looks up the hostname before the request ever leaves, and that leaks your real location and your real resolver. You went to all the trouble of routing through a Singapore phone, and then your DNS quietly announces where you actually are. So use SOCKS5H and then verify it. Hit an IP check endpoint through the proxy and confirm the IP and the DNS both line up with Singapore before you trust anything. Next, decide between sticky sessions and rotating ones and pick by the task, not by habit. A sticky session holds one IP for a set window of time. That is what you want for anything with multiple steps. A login, a checkout, any flow where the site expects to see the same person across several requests. If the IP changes halfway through one of those flows, the site sees a session that suddenly teleported to a brand new address, and that is a loud red flag. Rotating, on the other hand, is for high volume fetches where every request stands on its own. Scraping a long list of product pages, pulling search results, grabbing one URL after another with no shared session between them. There you want a fresh IP per request or per small batch, so no single IP ever looks busy. Now the mistake that kills more scaling attempts than anything else, concurrency. A mobile proxy is one phone with one radio. If you fire 40 parallel threads through it, you are asking a single handset to behave like a server, and it simply cannot. It will start refusing connections and dropping them, and from your side that looks exactly like an unstable proxy. It is not, it is you overloading one device. The fix is to cap your concurrency per IP to a handful of connections, not dozens. As a rough rule, keep it to 3 to 5 at a time per phone and watch your error rate. If you push past that and your timeouts start climbing, you have found the ceiling for that device, and the answer is to back off, not to push harder. 40 threads through one phone does not make you faster, it makes you blocked and disconnected. If you need more throughput, the answer is more devices, never more threads through one. You also have to design for the fact that mobile connections blink. A real phone hands off between towers, the signal dips, the radio drops and reacquires, and the data connection goes dark for a second or two. That is a real radio on a real network, and it is unavoidable, so your client has to expect it. Wrap each request in a single automatic retry with a short wait, so one tower blip costs you a retry instead of crashing your whole run. And when you hit repeated failures, back off properly. Wait a little, then wait a little more, then more again, instead of hammering straight back into a site that is already struggling. There is one more wrinkle. Carrier net drops connections that go idle, so on any connection you hold open for a while, send a small keep alive request every 30 to 60 seconds to keep the tunnel warm, otherwise you come back to a dead socket and blame the proxy. Here is a skill that will save you days. Learn to tell when the site is dropping you versus when the proxy is the problem. The hardest blocks to diagnose are the quiet ones. A site that is onto you often will not return a clean error. It serves an empty body, a stripped down page, a CAPTCHA, or it just lets the connection hang until it times out. From where you sit, that can look identical to a flaky proxy, so you switch providers and see the exact same thing because the proxy was never the cause. The test is simple. Hit a neutral endpoint like ipinfo.io through the same proxy in a tight loop. If that stays rock solid but your target keeps dropping or returning junk, then the target is blocking you, not the proxy. And the fix for that is never a new provider. It is slower pacing and fresh EPs. That brings me to pacing, because speed is what gets you caught. Real users do not fire a request every 50 milliseconds with perfect machine timing. They pause, they read, they click at irregular intervals. So put real delays between your requests, vary them a little so they are not perfectly even, and stay under whatever rate the site quietly tolerates. It feels slow, and that is the point. A steady scrape that actually finishes beats a fast one that gets every IP you own burned in the first hour. Pacing plus rotation plus a believable mobile IP, that combination is what holds up across tens of thousands of requests. Let me be honest about something, because I am not here to oversell. You might not need mobile for this at all. If you are scraping public data with no login at light volume off a site that does not put up much of a fight, then data center or residential proxies are cheaper and completely fine. Mobile earns its cost on the hard targets, the high volume jobs, and the data that sits behind an account. Do not pay for a real phone connection to scrape a sleepy public page that never blocks anyone. Match the tool to the job and save mobile for the jobs that actually need it. When you do need to scale up, the right move is more devices, not more pressure on one. Spread your concurrency across many phones, each on its own clean line, each carrying a small share of the total load. That keeps every individual IP looking like a normal subscriber while your overall throughput climbs. It also makes your whole operation more resilient because one device blinking or rotating never stalls the entire run. The work is already distributed across the fleet, so a hiccup on one line is invisible to the rest. That is how a serious scraper scales, by going wider across devices, not harder through a single one. The honest caveat to all of this is latency. A mobile connection is slower than a data center one, running roughly 80 to 350 milliseconds. That is the price you pay for looking like a real phone, and it does cap how much one IP can push. You make it back two ways. First, with parallelism across many devices, so total throughput comes from the fleet and not from any single line. And second, with the simple truth that a slower scrape which never gets blocked actually finishes, while a fast one that gets banned does not finish at all. So plan around throughput across your whole pool, not raw speed per request, and the trade-off works in your favor. If your scraper has hit the wall and the blocks have started, this is exactly the problem mobile proxies were built for. Singapore Mobile Proxies runs a real hardware farm. Genuine Singapore SIMs on Singtel M1 and StarHub sticky or rotating one clean line per task. There is a free trial so you can point Playwright at a real Singapore mobile IP and see whether the target that has been fighting you finally behaves. Use the code YT30 when you sign up. The link in the description takes you to the home page. Test it on the one site that keeps beating you and find out for yourself before you commit to anything. If this saved you some blocked requests, subscribe because the next video goes deeper on sticky versus rotating session design, when to hold an IP and when to let it move, and how to pick the window length that keeps your sessions believable. Thanks for watching and I will see you in the next one.